Hey there, welcome to another session of DrillDevops. Uh, let's begin the session. And this is the course content that we have discussed in the previous session. We have gone through each topic, what we are going to talk about in this entire training period, and we have discussed about the real-time projects, how we are going to apply these tools to achieve the pipelines, infra pipelines, and stuff. Please go through that session to get a better understanding of this entire training program. So in this session, we are going to discuss about introduction. So which means, so we are going to discuss about software development lifecycle, and we are going to take a couple of software development lifecycle models, and starting from Waterfall. We are going to talk about Agile Methodologies, and a brief history of history and evolution of DevOps, and then the key principles that we follow to achieve certain goals in DevOps implementation of project. And then we are going to discuss about comprehensive process related DevOps, what we are going to see in the projects. So let's begin the session. Okay, so this is software development lifecycle. So what does that actually mean is it's a systematic approach to develop a software or an application. So let's analyze this with an example. So let's suppose a developer, a business developer or a product owner came up with the requirement of building an application, saying like he wants some shopping application, which he can sell products via that, where he can have wide range of products like clothing, footwear, electronic devices and stuff. And he has given, he's coming and giving his all the requirements to the product owner, and product owner takes a requirement and start analyzing it with the set of team that is going to develop the application. So that is where requirement analysis comes into picture. And then requirements defining phase. In this phase, the people who are contributing to the application development starts analyzing that, which includes architects and then the developers, leads, project managers, and then the scrum masters. So all these people will sit and try to define the scope of the work, and then analyze what are the things that are needed, and then document the entire business and the end user requirements. So that is where defining phase goes. And then in the designing phase, so the architect developer architects and the system design architects, they are going to start developing a high level design, and on the process of on the entire development phases that they are going to design, like what sort of UI they should develop and what kind of languages they should use, and then they start analyzing the backend and how it should be on the payment process. All these things they are going to finalize by deciding the languages that they are going to develop that particular application, and they are going to decide databases and how they are going to monitor the resources, and the infrastructure that is required. Everything is getting built up here at the designing phase, and that is where once the designing all the requirements of technical requirements, all the resource requirements, everything is finalized, and then it goes to the coding phase. That is where developer architect divides these pieces into chunks of features, and assigns it to the individual developer, and developer starts building their code. So once they complete the building their code, they start um, publishing it in one common repo, and then that is where the code gets built and artifacts gets deployed on the UAT environment. So on the UAT environments, the testing goes on, and people start testing multiple rounds of testing, like functional, performance, penetration, and all these testing goes on. Once QA is approved, it goes to the deployment phase. Now in the deployment phase, we are going to see the end user or the business owner, you can see the application, and you can based on the application usage, customer usage, and the business owner use cases. He can ask to improve the build, the bug fixes, or he can enhance, or he can request to enhance the application based on the market standards as per the requirement, as per the market trends that is going on. He can request on that, and we can start maintaining it by fixing the bugs and putting the next sort of requirements in the next phase, and again start circulating this process. And then we are going to maintain, not only fix the bugs, we are going fix the bugs, but we are going to complete the we are going to monitor complete application infrastructure, and we are going to see the patterns, and then we are going to decide how infrastructure also can be improved on release by release. So that is what maintenance means, and on this entire software development life cycle. Okay, so let's discuss what are a few models or types of SDLC models that we have in the market. So it starts with waterfall model. We have waterfall. We have V model, which is validation and verification. We have rapid application development model. We have big bang model. We have spiral and agile models. These are the models that are available in the market, and then you can go through if you want. But then we in this course we are only concentrating on waterfall model, which is the first model in SDLC process, and the agile model, which is currently the market usage or organizations usage. So we are going to cover both of these in this session. So what made to choose which model on each software development or any application that you are developing? On what basis you can choose which model I should use? So there are certain criteria to choose any model that you want to apply it on your project. So you can think of having requirements, budget, timelines, complexity, development teams approach to develop the application, and the testing phases or patterns that application goes on. So we can consider all these things to choose any SDLC model that we want to apply it for the project. So that is how we can think of. So so let's talk about waterfall model in the next slide. So waterfall model is a traditional or a legacy first model that have been uh, started in the SDLC process. So so this entire uh, methodology, right? This entire waterfall model, it is a step-by-step approach. So whenever you start getting a requirement from the client or a business developer or a product owner, you start developing the application in phases, which means like you start taking the requirements and analyzing it and defining the all the use cases, all the requirements, uh, uh, all the patterns that you want to develop during the application development phases. When you are doing that until this requirement completes, all other teams will be waiting for the first phase to complete. So in the second phase, once that first phase is completed and approved, second phase goes in, and where high level design will get composed, and then once that is prepared, the people gonna have their brainstorming sessions. They are going to put the uh, high level designs of like UI backend, and they are going to design all those things like we have discussed in the previous slide. And then once that is done, then only they'll go for implementation phase. So once implementation phase, during the implementation phase, the actual code is getting developed, and once the code is developed, then only testing starts. If you see here, the diagram itself talks about it. It is step-by-step approach. You cannot directly jump in from first step to last step. It should be step-by-step approach, and all the other phases should wait until the previous phase should complete. So that is what the step-by-step process is. And when you talk about what kind of applications can be used waterfall, you can think of like any application which is straightforward and which is simple and small scale. Then you can think of uh, applying this model, and predefined. We have to have clear cut of requirements without any changes till the application gets deployed on the production. So mainly all the requirements, if you have all the bounded requirements without any change in near future, then we can think of having a waterfall model, because a waterfall model lacks the flexibility and does not handle changes during the phase by phase completion. What does that mean? Let's suppose I am in the phase of writing some code which is in the implementation stage, or I have written the code and it went on to hit the testing phase. Now, since each phase takes its own time, and by the time it goes to the testing phase, let's assume the market trend has been changed, and business owner or client came up with the new requirements and he wants to change the application requirements based on the market trends. Again, if we want to implement anything in the middle, we have to go back to the first step and start implementing right from the first stage. So, or else we have to wait to apply those changes till all the deployment is completed, and in the maintenance window he can come up and start giving the requirements, and based on that we are going to start again. So it is a tedious process, or waiting. It makes the delivery process slow, or it doesn't take any changes in the middle during the during the phases of development of the application. So this does not gel with the uh, changes very well, and it's a slow process, and then the efficiency of the resources is not utilized to the mark, be it the human resources or the infrastructure resources, or trying to hit any cost savings. You cannot do all those things in this model, as this is a long process, and a step by step process, which is mainly lacking to take the changes in the middle of the development. So that is why waterfall model is not applicable for rapidly changing or rapidly growing market standards application. So it does not gel with that kind of applications. So coming to the agile methodology. Agile methodology is an iterative and incremental software development approach that mainly prioritize collaboration, flexibility to accept the changes in the middle of the development, which is lacking in the waterfall model. It mainly emphasizes delivering the small chunks or functional increments of software features, which frequently enables multiple teams to adapt the changing requirements, and improvise the product based on the feedback once the application goes in testing phase. So this is how agile methodology can help you to enhance your application by application development by taking the changes in middle, during the process of development. So it will it has overcome the issue that have been there with the waterfall model. So that is why this agile methodology is so adaptive by many organizations outside market, where each team requires or efficiently involves or adapts this agile methodology in their project management, so that they can see the patterns and analyze and then implement the software development approach. So this is why agile is so effective for rapid change in market trends that are effectively directly affecting the applications. So that is why we go with agile methodology. And in agile, we have multiple models in agile methodology, where you can think of Scrum, Kanban, extreme programming. We have feature-driven development. We have lean software development. So these are some uh, models inside Agile. So our course mainly concentrates on Scrum and Kanban. So we are going to talk about Scrum and Kanban in the entire separate session by taking an example of Jira. Jira is our project management tool. Assuming Jira is a project management tool, I'm going to show you entire uh, Scrum board and then Kanban board and what's the main difference and when to apply each model to each application development to each application development. So we are going to talk about by seeing it on the Jira tool itself. History and evolution. So when you talk about history, so in so Agile started in initial phase of 2000, maybe around 2001. So that is when Agile get started buzzing and project team started implementing the Agile methodology. But then it has a few disadvantages of like collaboration between the teams and software delivery process gets slow because lack of communication and collaboration between the teams, and then and then the blame games that happen between the teams, like um, doesn't take the ownership of the issues, and there is a gap between development team and the operations team where people come up saying that this application is working in dev environment and this application is not working on the staging and production. And they can think of like many issues where blame game happens based on the team architecture and the teams involved in developing the project. So to mitigate this, somewhere in mid or towards the end part of 2000, like 2008 or 9, DevOps days started. So where people start analyzing development operations, collaboration, and the importance of collaborating the teams that are involved in the entire software development process, and started implementing the DevOps models. So it started in the first way. It started with normal technology stack, normalizing the technology stack, which mean like finalizing the builds, build tools, coding languages, and then set up proper strategy for building, deploying, and testing, and then deploying. So first, it started with the standardization, technology standardization, technology stack standardization, which means finalizing the tools and apply using them only irrespective of multiple tools to build same code. So that is where it started. And in the second phase, it started standardizing and reducing the variability. Variability in the sense, if you consider infrastructure, there could be a variation between development environment, staging environment, and production environment. So this changing environment should not happen between the infrastructure in between infrastructures. It should not pollute the infrastructure. All the environment should be identical and should be maintained without any variations. So uh, such kind of things have been reduced in the second phase, and people started showing the importance of DevOps, where once it is standardized, the manual tasks or repetitive tasks gets easier, and once the uh, stable process with set of guidelines to follow that process. Once you set those things in place, and the process started getting smoother and collaboration got bit better compared to previous. In the third part, expansion of DevOps practices, that is where the CI/CDs came into picture, continuous integration, continuous delivery, deployment, and then the continuous testing, continuous monitoring, continuous feedback. All this came into picture, and people start adopting it in their uh, development process, where code has been integrated with multiple tools, like code. Code goes with different tools where it can uh, build the code. It can scan the code, and then once the code is built and approved from the scanning, then we will push that code binary to the artifact, and then from there it is going to get deployed in the environments for testing, and then once testing is approved, then it goes to the production deployment. So all these things got automated, and people started building through those CI/CD tools, and started implementing the proper cloud, where uh, infrastructure moved from on-premises to cloud, and people started using the public cloud by launching the infrastructure on the UI, then pushing their applications to the cloud, and hosting there. That is where the expansion of DevOps practices happened, and then in the fourth stage, automation of infrastructure happened. So when in the previous stage, infrastructure was manually provisioned from the UI or from the on-premises, by launching the UI and taking the normal manual steps for launching VP, EC2 instances, VPC. If you consider AWS, all these things have been done through manual process. So when you have this kind of infrastructure which is created manually, you cannot have a track of changes on the infrastructure. Like suppose you when you have a team of huge numbers, like if you have a team of DevOps, team of like 4 to 5 or 10 members, you cannot track who is doing what, and you cannot have a proper history of who changed or what. So to mitigate that issue, people started writing the code for infrastructure as well by using Terraform or Ansible or AWS CloudFormation. Once this came into picture, people started writing the code and pushing the code to the source code management tools. So once it is pushed, based on the source code management tools helps you to track your code changes, and helps you to only merge the changes that are approved. So that is why people started writing the code, and only the certain leads or people who are managing the projects can only merge the infrastructure changes to the environments. So once that is changed, automatically build gets triggered, and it is going to apply the changes on the infrastructure part. Build here in this sense, it is not actually code build, it is actually a Terraform build where you can actually build the code, plan the code, and apply it on the infrastructure side. So that is what build means. The other build means where you can build the program or a coding language that is to create an application or develop an application, and it is being hosted on the infrastructure that is being created. So that's the main difference. Coming to provide in stage provide, so we have still till stage 4, it is all automated infrastructure pipeline, but not a self-healing or a self-satisfied self-provisioned infrastructure. What does that mean? Let's suppose in the previous example we have taken shopping application, and taking that as an example, if you talk about big billion days or any days that you want to give offers on weekends. So during that time, your application attracts so much of attention from the users, and users start using your application, and you get high even number of requests, or you get huge traffic to handle. So during that process, if you are not managing your code well, if you are not managing your infrastructure well, then there is a quite bit of chances that gets your application down because of the huge volume of requests that you are getting. So to mitigate that, in stage 4, what they are going to do is they will plan these kind of big billion days, Thanksgiving days, and these stuff. They are going to plan, and they are going to increase in hand even before it comes. So by checking the previous patterns and all. So that is how they are going to increase it. But when you increase in hand, even before your traffic got started, it is not a reliable way, because it is going to consume a lot of resources, and you are wasting your resources, not effectively utilizing, and you're pricing your infrastructure budget, which is again a not very good efficient way of implementing the DevOps model. So DevOps model mainly emphasizes to efficiently use the resource and reduce the cost based on the project usage. So in stage 5, how it has changed is like we implement a lot of methods or a lot of things to handle these high load capabilities, or whenever your application goes down, automatically self heal capabilities that we are going to do, or if there is something wrong with your production application, we can roll it back, we can have all the strategies. There is very less margin of downtime. So how does we do that, how does we achieve that? So basically, if you are talking about high volume of traffic that coming to your application, you can think of having an auto scaling where if you attach auto scaling to the existing application servers, it is going to get automatically scaled whenever it meets the threshold. In auto scaling, we are going to set thresholds. If my CPU percentage goes 60 or 70%, or if my incoming request, incoming traffic or request comes over a period of time, like count, if we give based on that count, it starts scaling your application, and once it is down, it is automatically scales down. So that is where effective use of self service capabilities or self serving capabilities comes into picture. If let's suppose your application gets down, you should it should automatically create a horizontal server where it can serve the load. So you can have, if something goes wrong with the application itself, because of the bugs that have implemented, we can have proper rollback strategy where with one click it should roll back to the previous thing. So we should have a proper disaster recovery process way to store our configuration data, configuration management data, or any sensitive data that we are handling to maintain the project. We can have a disaster recovery system where you can handle those things in a better way. So that is where evolution of DevOps came in. And then if you talk about the latest process, it is being developed in such a way that it has implemented DevSecOps as well. So what does DevSecOps means? Development, security, and operations. Security here mainly concentrates on code security, application security, infrastructure security, network security. So all these have been constitutively combined together as security and implemented in the DevSecOps. So we will use for code quality check, we will use SonarQube or Veracode for checking your application artifact or a SaaS testing. We can use check marks. Static application security testing, we can think of using check marks. We can use Qualys scanning for VM machines or Docker images. We can use Snyk for scanning Docker images, code scanning. We can use proper certificates to have our applications secured, SSL certificates. Managing proper SSL certificates helps you to secure your network. So all these things helps you to implement these DevSecOps, and that is what the companies have been working around to improve the DevOps to DevSecOps. So that is what evolution over a period of time and stages that have been involved in setting up that evolution in DevOps world. Coming to the principles and goals that we are going to achieve by following these principles. So DevOps is basically driven by a set of goals, set of principles to achieve the goals um, uh, that have been defined, or going to get benefited by other teams by implementing the effective use of these principles, or set of guidelines that we impose on the project that is going to help you to have a stable environment, stable, reliable environments. How we are going to implement and all, based on the project team requirements and project flow of development. All these things constitute the implementation of principles and then achieving the goals. So first thing under principles, collaboration and communication. So which is again this actually emphasizes the collaboration between the teams, whichever teams involved in software development or application development, like development team, QA team, DevOps team, monitoring team, if there is any, or if there is any database team, whichever teams involves, they have to combinedly work together to achieve one common goal of delivering the software in a reliable and faster manner. So that is what the collaboration means. And communication. Communication is very important medium to achieve this goal of releasing the software rapidly. Because if the teams are transparent enough and provide proper communication of what they are working on or what they are being stuck up, other teams can pitch in and solve the problems, and that is where the open communication or transparent communication should be. And DevOps principles emphasizes communication and collaboration highly. So automation, again, automation is a keyword where it's a technically implementation thing where you actually automate the repetitive tasks, and you are going to reduce the time consumption, encourages effective utilization of resources. We can think of automating the builds, code scans, testing, packaging, deployments, infrastructure, and all these things can be done through automation by using any scripting or any framework of whatever is required during that process. So automation also reduces the errors, accelerates the delivery process to focus on better work or qualitative work for the developers instead of doing the repetitive tasks. If we do automate them, they can concentrate on whatever is required for the team to that is adding value to the product. So that is what automation means. And continuous integration and continuous delivery. This is again a topic that involves the automated build process, automated delivery process, automated deployments, automated testing and monitoring. So all these things constitute to DevOps, where it helps to smoothen the software delivery process. So it doesn't have any clumsy works or manual things that gets involved in between, so that you can think of very less chances of reducing this software delivery timelines. So that is where continuous integration and delivery helps you to enforce the teams to deliver the things in a better way, as these are completely automated and it's a single click buttons where you can get a software delivered on any environment of the choice. So coming to infrastructure as a code, what does this infrastructure as a code mean? Like I discussed in the previous session, previous slide, we have discussed about Terraform or any cloud formation, AWS cloud formation tool that helps you to write your infrastructure in code terminology and apply it on multiple environments. You write these reusable resources in one common module and try to apply it in different environments, or try to call these modules whenever you need them to get provision. So that is where infrastructure as a code comes in, and we have infrastructure pipelines that are going to get triggered when there is any change happens in the code base. So that is what infrastructure as a code means. And monitoring and feedback, again, it's such an important topic where we are going to monitor application security, application network, and we are going to monitor infrastructure and other parameters, whichever business needs. Based on the feedback that we are going to get from the monitoring team, we are going to apply those patterns or the changes that we have observed in the previous days or previous release cycle. We are going to apply those things, and we are going to get the feedback from the customer as well, take that as an input, and based on this pattern we are going to apply changes to application as well as infrastructure, such that it is going to get better and better in each release. So goals, by using these principles, what are we going to achieve? We are going to achieve accelerated software delivery, which I am emphasizing in previous slides and this slide as well, by collaborating, communicating, automating, implementation of CI/CDs, infrastructure as a code, and monitoring and feedback. All these process basically constitute in delivering a software in rapid, faster manner you can think of. So that is where the accelerated software delivery process happens, and in this entire process, it will enable the development teams to release new features, updates, bugs more frequently and reliably. So this will also ensure to respond to quick changes in the business needs, and transformations that are needed to apply to the existing application. It is going to take that in a better way as per the market needs. And then reliable and stable systems, again, this means like we cannot have any failovers or any incident that comes from the end users. If we are going to get how well we are equipped, or how well we mitigate this downtime, that is where our system reliability and stability matters. So DevOps focus on resolving or restoring the services quickly with continuous monitoring and automated rollbacks mechanism. So which will whenever some production service gets down or gets an issue, our backup mechanism or rollback mechanism takes in from there and roll back to the previous version. So and then this DevOps team enables to respond these kind of scenarios rapidly, and try to reduce the downtime or business impact. That is where reliable and stable systems comes in. Enhanced collaboration efficiency. Again, this emphasizes more on collaboration and efficiency of resources utilization, be it human resources or infrastructure resources. So it mainly emphasizes the breakdown communication barriers between dev and QA, and whatever teams involved, operations team, and any product management team or whoever involves. It breaks the bridge between them. It breaks the issues between them, and then this helps to understand the business requirements better, right from the requirements phase to till the monitoring team, right from the requirement team to till monitoring team. Everyone gets a better understanding of what business needs are and requirements are, and act as per the business needs. That is what this enhanced collaboration and efficiency can do to an software development process. Continuous integration and continuous delivery. Again, this is an automated complete build and release lifecycle, where you can completely automate your entire process, and you're going to achieve this by implementing the CI/CDs, infrastructure as a code, and few automations that minimizes the manual intervention. Cultural transformation. DevOps is again not completely about technical thing. It is about cultural transformation as well. So what does that mean? So basically, it is a process and a practice on daily basis on for each team to have cultural transformation of or cultural transformation of previous methodologies to current DevOps model. So it emphasizes mainly on organizations giving better visibility of multiple teams, and their roles, promoting their collaborative, learning oriented, and blame free culture. So which means like whenever something happens or some error or failure happens, we cannot sit and blame each other. We rather we can sit and sort what kind of issue is that and how can we mitigate without that repeating in future. So that is what we can think of, and that is what learning oriented phases of DevOps. That this helps each other to self grow as an individual who is contributing to the team, and these things can be transparent so that it's get visibility of everyone, and try to not repeat the same mistake or self learning that have been done in previous sprints or previous release cycle. So these are the goals that we are going to achieve when we have principles set in place. So let's discuss on comprehensive overview of DevOps. What exactly at technical level we will be implementing on the projects. So so developer starts developing the code, and then he pushes his changes to the some common code base, which we can consider GitHub as a source code management tool. So all the developers commit their changes or push their changes to one common repo inside a Git. So that is where on the Git side what we are going to do. So on source code management level, we are going to provide branching strategies. So we will be giving proper set of branches, how they are going to do the development and where they are going to raise merge request and how they are going to create releases. We are going to give proper branching strategies at Git level. So once the code is being merged on the branches, so our build gets triggered. So build gets triggered, and we are going to build the code. Let's assume again same shopping application, and all the features got developed and it is being pushed in the source code management tool. In the next line, we are going to build the code. So considering that we are developing our application in the Java code, let's assume we are building with the Maven tool. Maven is a build tool where we are going to create a binary. So we cannot give the end user the code, right? So let's suppose if we want to install VLC pair in your Windows machine, how do you start it? You cannot take the code source code and build the code and get an application out of it. You need a executable file where you can directly download the executable file or a binary. Just run that by putting next install. That is how you want your application to be. So to get that, you have to build the code. So to build it, you need a tool. That is where you have one build tool where you can build the code. And during the build process, you need to test the code whether it is at whether it is maintaining the standards, industry standards or company standards, and it has been very secure with all the vulnerabilities checked. And if there is any issues related to the code coverage or test coverage, we are going to check. And during that entire build process, with any sonar cube or any code quality check tools, static code analysis tools, we are going to do that. And once that is done, we are going to we are going to release the code where we will be giving one where we'll be releasing the artifact, and then in this artifact we will be having snapshot artifact and the release artifact based on the branches. So again we'll be deploying the artifact based on the environments. So we will be deploying the, if it is a staging application, a staging environment or UAT environment, we are going to release a snapshot artifact into the testing environment. Once it is tested, and then we are going to create a release, and then from the release branch we are going to create a release artifact and deploy it on the production. So that is where our application goes live and people start using it, and from there we are going to monitor the application network, application logs. We are going to monitor infrastructure that is hosting the application. All these things we are going to do. So once that phase is done, we are going to operate that entire infrastructure or any task that is related to the application or infrastructure. We are going to manage that using one configuration management tool. It could be Ansible or it could be Chef, based on the environment or project specifications. We can think of using Kubernetes as a platform where you can deploy your application, and then or else you can use Ansible to deploy your application on any VM machines like that. Once all your deployment happens and infrastructure is up and running for serving your load, you need to monitor. You have two things here to monitor. One is application monitoring and the other one is infrastructure monitoring. Again, we have various types of monitoring under this. Logging, we can use log monitoring tools like ELK Stack or Splunk, where you can see the application logs, and then you can have the infrastructure resources monitoring by using Prometheus or Grafana, and we can have a lot of monitoring tools. Based on this entire process, we can think of having a pattern by observing all these patterns in the monitoring phase and on the release cycle, and then once the application goes live, the inputs or the bugs that we are going to encounter or get created from the end user or business owner, we are going to start a new planning in the next release where developers get the new requirements and bug fixes to the existing ones and start building the code. Again, this phase continues where build phase goes on and it is going to test the application code, the artifact that is getting created using check marks, like that. All these things goes on, and then at certain point, this um, this complete cycle will be in loop where application delivery process gets better and better, and you have a stable application where you can just keep on adding the new features seamlessly without any interruption or without any change in the environments. That is what DevOps can do over a period of time to any application, making the delivery process reliable, stable, simpler, and faster manner. So this is about a comprehensive overview, and we are going to discuss each phase that we have talked here in detail in the next sessions, and we keep looking forward for you to be available in the next sessions. And coming to the next session, that in this free demo session, we are going to talk about Agile methodologies, where we are going to see the Jira board with Scrum and Kanban dashboards on which tool, which model can be implemented on what basis and how it can be architected as per the project requirements. So I'll be showing you the Jira, live Jira, and uh, give you a comprehensive overview of Scrum and Kanban and the implementation part and the use cases. In which use case you have to go on what model. I'm going to talk about that in the next session. Thanks for your patience, and we keep looking forward for make DevOps easy for you guys, whoever wants to start their career in DevOps. Should you have any questions, please shoot out an email or reach us on these available contact points. We have a Play Store app, which is DrillDevops, Google Play Store app, and then we have a YouTube channel where you are going to see this video in YouTube, and we have Facebook page and Instagram page where you can reach and get the updates from. And then thank you for the session, and then we will keep growing towards the DevOps. Thanks all.